Hi, in this video we are going to be talking about how we can write a system as a matrix equation. Then in our next video we will discuss how to solve it. Now, matrices are really a good way for us to solve systems of equations. When we say a system, it means more than one equation, and that's of course in more than one variable. So it could be two equations in two different variables, x and y, three equations in three variables, like in this case x, y, and z. So let's first discuss how to change that into a matrix equation. We are going to look first at the coefficients of x and y in the equation. We're going to align those coefficients in a matrix that we call the coefficient matrix. So let's do that first. We're going to take a matrix, and of course we have two variables, which means two coefficients, and two equations. So my matrix is going to be a 2 by 2 matrix. And I'm going to start writing the coefficient of x of the first equation, then the coefficient of y, which is 3, then the coefficient of x of the second equation, and the coefficient of y. Now, we need to be able to know that when we have a coefficient matrix, the first column represents the coefficients of x, which is a variable. The second column represents the coefficients of y, which is the second variable. Make sure you don't switch them. Make sure your equations are in standard form before you write. Otherwise, you might get confused and your matrix equation would be wrong. So first column should represent the coefficient of the same variable. So this is the coefficient of x in the first equation. This is the coefficient of x in the second equation. Also, each row represents the coefficients of one equation. So these are the coefficients of the first equation, coefficients of the second equation. The second matrix we're going to do, which is multiplied by the first one, is the variable matrix. I'm going to put x here and y here. Why? Because when we multiply, if you remember, if you want to multiply, you're going to multiply the row of the first matrix by the column from the second one. So I will end up multiplying -6 by x, which makes sense because here I have -6x, plus you're going to multiply 3 by y, which is 3y that you have in the same first equation. When you want to multiply the second row, it's going to be 4x plus -2y, which will end up to -2y. So take care that the order of the variables in the variable matrix does make a difference. You have to put the first variable, which you have got its coefficients in the first column, here on top. Then the second variable in the second row. Okay? Now we are done with this. The last matrix we're going to represent is what we call the constant matrix. It's the one that has the answers for both equations. So far, this first row represented the coefficients in the first equation, so we put the constant here. Also, the second row represented the coefficients of the second equation, so its constant goes here. We call this constant matrix. So coefficients matrix multiplied by variable matrix, you will get the constant matrix. What about if we have three equations like that? Now we have three different equations, so they will be represented in three rows. And how many different variables we have? We have x, y, and z. So that's three different variables, so that's going to be represented in three columns. So again, my coefficient matrix here is going to be a little bit bigger. It has three rows because I have three equations, and three columns because each column will represent a variable. Now in the first equation I have 2x, so I'm going to put 2 here first, then 3y, and I don't have a z. This means that the variable z has been multiplied by 0, so its coefficient is 0, so this is where a 0 goes. If I look at the second equation, the coefficient of x is 1, then -2 for y, and also 1 for z. My third matrix, I don't have x, which means x has been multiplied by 0. Coefficient of x is 0. Then I have 6, y, and -4z. This is your coefficient matrix. 3 equations, 3 variables. Each equation is represented in a row, and each variable is represented in a column. Now, the variable matrix, again, as we said, order matters. The first column here represents the coefficients of x. X goes first. Second column is the coefficients of y. Then y comes, and the last one is the coefficients of z. Is that correct? Yes, it is. Why? Because when I multiply, I'm gonna multiply that row by the first column. So it's gonna be 2x plus 3y and 0z. So I have no z. Look at the first equation, 2x, 3y, and no z. And it's the same for all the rows for the different equations. Then the last thing you have is the constant matrix, which has 12 as a solution for the first equation, 9 and 8. That's it. This is simply how we are going to write a system of equation into a matrix. In our next video, we're going to discuss how are we going to solve this system using matrices.